Did you guys get your notes and whatnot from the front? There were a few more. Okay. Limits. We talked about the definition. Well, first we previewed calculus, right? And we figured out that calculus needs limits. And then we were like, let's talk about them. And we talked about, first of all, an informal definition, which moved on to notation. We like kind of went all the way down to notation. And if the limit exists, then the limit of the function f of x as x approaches a is L. L is a y value. A is an x value. We talked about different ways limits can occur and can appear. And now we're on starting to solve. Now guys, we're not applying limits. We're not answering the two big questions of calculus yet. But we are learning the concept and how to how to solve limits at their most basic. So the first way that we're going to learn how to find limits is numerically, using a table. This is more investigative, anyway, investigative, that's right. More experimental. In that, I suppose we'd be doing this by hand, but there are so many decimals that will appear. It's going to be much faster if we use our graphing calculators, hence why we got you guys to get them. Once you finish writing down, you don't even need to write the example if you don't want, but I figured it'd be good to show you. I want you to make sure after writing this down that your calculator is in function mode and that you are in your y. Your calculator is in function mode and that you're in your y equals. And if you want to go above and beyond that, you would want to go to your table setup and make sure that the independent variable is not automatic. Instead, ask is selected. Bless you. Thank you. Good.
Press C? Wait, no. That's a wrong language.
It worked.
Oh well.
So it went to Dominican Republic. What was it, Nicaragua. 2 years ago. She had taken French with Madame, like all or whatever year. And so every time if you were talking in Spanish, she would like take she even did respond in French with them. So it was like she got on pretty quickly to the basics.
You know, your camera speaks French.
This is how mine.
That's really juicy. Amanda just has the giggles. What can you say? You guys ready? Okay, so your calculator is on. It's in function mode. You're in your y equals. Function. So we add a parametric, we add a polar. We introduce parametric and polar, but we will not be applying calculus to them. We're not that advanced.
This is our normal mode.
It doesn't matter. Simultaneous or sequential, they're both. Does anyone see a function on the page anywhere? I see a notation for a function and I see an actual function. What actual function is on the page?
Limit as x approaches to
3x minus 2. Good, Ella. 3x minus 2. But thank you for the rest of you who are trying to participate. So we have 3x minus 2. Okay? Why did I say that that's the only function on the page? Where does the function go in this notation? The inside. Does that make sense? Limit is an operation. I'm not sure if I should actually call it that, but that's okay. We'll say the limit is an operation. It's a mathematically defined. What would I actually call it? That's a really good question. I'll stick with operation for right now. Although operations are usually like addition, subtraction, multiplication, division, so I don't know about that. But a function is 3x minus 2. Now, We're gonna get back to working with that function in just a second, but first of all, I need to tell you how a table works and how we use it to examine the values of f of x as x becomes closer and closer to the number it's approaching. Hey, what's the notation for what constant do we use to symbolize the number it, aka x, is approaching? A. Careful. X approaches A. A is an x value. Wrote that down on the last page, right? 2 pages ago. X is approaching A. A is the x value. L is what the answer is, and that's what f of x is approaching, if it is approaching indeed anything from either side. Either side of what? Okay. Guys, in a table, don't we usually put the x values and then the f of x values? Right? Don't we usually put the x values and the f of x values? Who is x approaching? A. And then to approach A, now here's where it gets a little weird. To approach A from either side, we need to come from what we would technically say is below A and from above A. From below A and from above A. Now, they can get a little confusing when you start talking about positives and negatives, but we'll see them when they come and we'll deal with them then. From below A and from above A. Now technically there are going to be multiple points that we're finding. So it's not like it's just one, but we're going to be finding multiple points from below and from above. Plugging in from below, plugging in from above. And our goal is these points that we plug in are both, the x values are approaching A. And as x approaches A, what are we looking at? What f of x is approaching. If indeed, as you come from below, the y values seem to be converging, all words that we've used before this year. The y values seem to be converging, approaching a single constant, then the limit will exist and we will say, whatever that number is L, is the limit. Okay? So what we're trying to think about as we're plugging into a table is, first of all, how can we come from, bless you, from below and from above A? How can we come from below and from above A? And we're asking ourselves the question, what are the y values doing? Now, truly, at the core of a limit, we're actually not asking what do the y values equal. We're not asking that question. We're asking what are the y values approaching. Once again, we're not asking what the y value is, even though sometimes it's the same thing as the limit. We're asking what are the y values approaching. So let's go ahead and give an example. So, you guys, in your y equals, you see a function in this example, 3x minus 2. I want you guys to go ahead and plug in 3x minus 2 into your graphing calculator. I want you guys to plug in 3x minus 2 into your graphing calculator. Question. What should I plug in for my a value for this example? Good. 2. Good. Now, in your graphing calculator, it's not super nice. You can't like put a 2 in the middle of your table. It's kind of awkward. So we'll think about how to visualize that in just a second. We might do them totally separately, do the table separately. Do the table approaching 2 from below, then do the table approaching 2 from above. We'll see. Or there is another way of thinking about it. I said, if you guys were able to get ahead enough and listen to my directions, I did say go to table setup, aka second window. And for your independent variable, make it ask instead of automatic. Automatic says, oh, hey, I'll give you 0, 1, 2, 3, 4, 5, or wherever you tell me to start from. This one would start at 7 and go by 10. 7, 17, 27, 37. That's awkward. Long story short, we need to get closer and closer by smaller and smaller steps. We want to get arbitrarily close. So going by a set amount isn't going to work for us. Doesn't cut it. So we're just going to go ask. When we go into our table, if you guys have anything there, just clear them all out. Clear, 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 clear. Okay. Now, the approach from below is a little bit easier a little bit easier than the approach from above. And actually, before we plug into our table exactly, let's talk about what x value values. Let's strategize what x values we should use. Question. If I was to start, don't write it down. If I was to start at, I don't know, like -10, how can I get closer to 2? -5. I could go to like 1. But question, in between 1 and 2, is that super close to 2? No, it's 1 unit away. And if that was in miles, it's still quite a ways away, right? So instead of starting from far away, we're going to zoom in super close. And that's just the beginning. 1.9, how close is that to 2? Pretty close. Coming from below, does that make sense when I'm starting at 1.9 and not like 2.1? 1.9 on a number line would be below 2. So if you think about a quick little number line, just to help us out, this is just the x's. If 2 is here, 1 is here, 3 is here, we're zooming in and we're trying to really get close to 2 from below and from above. So 1.9, that's pretty close. Let's get even closer. 1.99? Yep, that's closer. Instead of being 0.1 away or 0.01 away, can we get even closer? Let's go one more. 1.9 is close. 1.99 is closer. 1.99 is closer. 1.99 is closer. Closer. 1.99. Still not 2, but we're getting even better. Right? Now question. To get closer to 2 from above, it's a little awkward. I'm going to go to the end of the table. It's okay. No one says if you can't start from the end, right? 2 point, I'm going to get in close, 2.1. I'm going to start at 0.1 away, but 0.1 above. Now how can I get even closer? 2.01. Not 2.11, that's actually even further away. 2.01. Now I'm only 1/100th away. How can I get even closer? And then, did we do 4 on the other side? Okay, so we'll do one more. 2 point, this one isn't as much fun to say. That's okay. 2.1, 2.01, 2.01, 2.01. We're getting closer, still not technically at 2. Which could make a big difference in some applications. But in a linear function, trying to find a limit, not a big deal. Linear function has no discontinuities, has no weird breaks or jumps, has no vertical asymptotes. So let's go ahead and see what happens as we approach on our graphing calculator. The weird thing is our graphing calculator, you kind of have to go from the left to the right, and you can't really deviate much from that. Even though you guys can't see it, you know that my first value is truly 1.9, right? So if we do 1.9, if we do 1.99, if we do 0.1 point, stop flashing, 1.99. If we do 1.99, yeah. What seems to be happening? Sure looks like it's approaching 4. Is it converging? I don't know. I guess we could just really go crazy and do less my smart board doesn't want to work right now.
Doing something. Going soon.
Let's go.
We don't want to be at 2. We want to approach 2.
Another one.
Wait, I went to 2. No, I was supposed to be doing 1. No, that's not what I wanted. Okay, hold on. It's not going to work. Oh, you know what? Screen. Cancel. Escape. I don't want that. Go away. Is that better?
Restore.
More accurate that way. Because if you just get on it, you might get a little bit off. But if you drag it, then you can get it more precisely in the middle. Okay, coming back. Better. Wait, I wasn't trying to get to 2. I was trying to get to 1. I did get to 1. But remember how it has to round at some point? You can't fit that many 9s, so it rounds to show. So what happened over there? I got to 4. Oh. I got to 4. It had too many places and it kind of comes around it. If I do a little bit less extreme, 1.9, okay, we'll do that instead. It still got to 4. No, it didn't. It's just getting closer and closer and closer. Does that make sense? What happened on my other one is that it kept on going and then I said, oh, I have to round and then messed it up. Anyway, what seems to be happening as I come from below 2? Approaches 4. So if we were plugging to our table, we would have 3.7 on this one. Oh, 3.7, 3.97, 3.99. No, too much. 3.7, 3.97, 3.997, 3.999, 7. I seem to be approaching 4, right? From below, I seem to be approaching 4. That's a really bad notation, so let me go ahead and say this a little bit better. I'll say from below 2. F of x is approaching 4, as best I can tell. For a linear function, it doesn't behave weirdly, so we can go ahead and say that is true. We're trying to also answer the question from above 2. What is f of x approaching? So now it's my job to go from the other direction. Some of you have already done that. Thank you. I'm going to go ahead and make sure there's room for all of my points. So I need 1 and a 2 and a 3 and a 4. So I need 1 and a 2 and a 3 and a 4. So I'll come back here. Okay. And we'll do 2.000. 1, 2.00, 1, 2.0. Come on. 1, 2. Now it's kind of backwards because it's backwards what you think, and maybe you guys can realize that's why I'm showing you what I'm showing you in the sense that we think about it beforehand, then we can show our table and say, hey, from below, got it, from above, got it. So I'm just going to quickly go ahead and write in what our calculator has shown us. In that, 2.1 is 4.3, right? 4.03. Yeah. So what does this show us? Whether we come from below 2 or from above 2, f of x seems to be approaching what? 4. So therefore, without even knowing what's going on at 2, it doesn't truly matter for a limit. The limit as x approaches 2 of my function 3x minus 2 is 4. Why? Because the informal definition says, as x approaches a constant, if f of x approaches a single constant from either side, it has to be from both. You should say from both sides. Whatever side you come from, as long as it's going to a constant, that constant is L, and the answer is L. So you guys, I want you to go ahead and try what to do with, oh, it's the same thing. We'll get back to that. This one. Ready, set, go. Fill out the table. Plug it into your calculator. See what's occurring. So we're reorienting life a little bit, changing the problem for the one we have at hand. Changing up our table, right? Are these values appropriate anymore for this problem? No. No. Delete gets rid of the points in your ask table. middle of your table? Sounds good. What are some values that you decided to do in leading up to -3 from below? No! Yes. So tricky, the negative numbers. Think about a number line. -3 is here. Wouldn't -4 be on this side and -2 be on that side? Yeah. We just have to orient our thinking to make sure we understand. So what would be on this side? Well, not even that, so we're trying to get zoomed in, right? -3 point something would be the below. -2 point something would be the above. So then we can say, okay, from below, -3.1 sounds good. -3.01 sounds good. Maybe we can see it with -3.001. Want to try it? And we can do -2.99. -2.99. Maybe we can do it just with a bit fewer points. So as we go to our graphing calculator, we can go ahead and start with our -3.1. Then we can go to our -3.01. Our -3.001. Then coming from the other direction, -2.99. -2.99. -2.9. What's going on here? Now approaching a nice, like, I don't know, whole number, right? A, it's a negative. B, it's a decimal. C, it's a repeating decimal. You guys see what's happening? -1.6, -1.66, -1.666. Did anybody try -3.0000000 see what happened? It rounded, but wasn't it -0.1666666? Don't the sixes start showing up? Or if you do -2.9999999, that starts having more. -0.16666. Wait, we saw this decimal just the other day, yesterday. It's a repeating decimal. What is negative, or just in general, 0.166666666? 1/6. So, in filling in our table, we can go ahead and fill in our negative 1.639. Okay. And negative, no, it's not 1.6, so negative 0.1. 0.1639. Negative 0.1664. Negative 0.1666. But it keeps going. And this one specifically would be 666, and then technically 4 if you rounded it, or it'd be 3, 8, yada, yada, yada. Coming from the other direction, we get negative 0.1695. Negative 0.1669, probably with 5. Then we get negative 0.1667, but that's only because it's rounding. If you go look at that decimal, if I was to go down, it's not truly a 7. Oops, too far. It just has 6669, and so it rounded up to a 7. So what would our, remember, once again, it doesn't truly matter what's going on at -3. Whether we go from below -3, remember the limit as x approaches a, which is -3. From below, then from above, f of x is approaching, seemingly, -1/6. From above, f of x is approaching, seemingly, -1/6. So then from that conclusion, since from either side, from below, from above, whichever direction you come, it's approaching the same constant, then we can say the limit as x approaches -3 of my x plus 3 all over x squared minus 9 is -1/6. Yeah. Did you use the alpha button? Is that what you're doing? trouble with your calculator? Alright, so let's keep going. Oops, I'm not, I'll mark across the page. Did I skip something? What did I skip? We'll go back to that. Graphically. Graphically. Approaching the graph from the right and the left of the number. We've been saying from below and above, which technically we could also use directions from the left, which would be below of the number line. From the left would be below. From the right would be above a number. Graphically, remember, x is once again approaching. So the number x is approaching, isn't that basically wording to describe a? It's not, no. The number x is approaching is just what we would call a. And we come from the right and from the left, from below and from above, a. But what we're looking at for our answers are not the x values. We're using the x values as a guide, but guys, what kind of answer is a limit? A y value equals L, f of x is approaching. So we're looking for our answer for the limit at the y values. Why? Because we're trying to figure out, is there an L? Okay? Is there a limit? And I have an example drawn below. Let me zoom in just a little bit. So I have a function f of x. The graph of the function f of x. If you guys notice, there are a few points that are actually drawn on the graph, and they're for a very particular purpose. No holes, no vertical asymptote, please not seemingly. It actually, let's just say it connects at this point to our 1. Let's say it's maybe a square root function that's been shifted up. Could have been shifted up 1. So we have the square root of x function, shifted up 1. It hits at 0, 1. It hits at some arbitrary x value before 1. Hits at arbitrary x values after 1. And the limit, if you think about the definition of what we were doing in our table, we can see that on the graph in that if we know a is 1, if we're looking at a, we can go up on the graph at a, but we're not carrying, remember how I put the x through that point? For a limit, we're not carrying necessarily what's at the point. We're carrying what's going on around the point as you come in from below and in from above. So the x needs to get towards 1. So we can think of an x value. That's like a half right now. We need to get in closer. Maybe 0.9. Closer, 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 closer. We don't necessarily care what's going on at that actual infinitesimally small space. We're caring about what's going on as we get closer, 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 as we approach from below, and as we get closer, 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 these x values come up here to the graph. We're looking at the y values. So as the x approaches, as the x approaches, as the x approaches, we're asking ourselves the question, what's going on with the y's? What's going on with the y's? And guys, without even getting a table out, can you tell what the y's are approaching as the x's come in? 2. Yeah. So, we identify what a is. Well, first of all, we identify who is f of x, right? We get the graph of f of x. Then we zoom in on that graph of f of x and say, okay, now who is a? And we find that placement. We can go to the graph, but we don't truly care about, and you'll see why I keep on saying this, we don't truly care about what's going on at that actual position. For limits, what we're looking at is, as the x's get infinitesimally closer to a from below, what are the points doing, and hence what are their y values doing? And hence you can see over here, we're looking and asking, are the y values, whether you come from below, whether you come from above, those points that would match up, those y values. The approach is 2, so therefore I would answer the limit as x approaches 1 of f of x, looking at its graph, is 2. Okay? Now let's see if I trained you well enough. We have 45 seconds. I'm going to give you a problem that even some of my calculus kids still miss when it's on an AP exam question. Whoa. What would be your answer for this one?
We should take the time.
Yeah, just one out of 65, I'm not so sure about that.
We have enough information, let's do this. We know two things.
How much more do you guys have to go?
We know there's not, even though there's a hole, it's still a point. And we know, use LN of X. That's it. Let's go. We're ready. If anything, just plug in LN of X.
Yeah, I think that's some more. I think that's some more.
On MedLab, I checked and it said I had serums for chapter A and B notes and chapter A and B homework.
Let me make sure I didn't, because I filled in some things after I updated. For notes, I filled you in for chapter 10B homework, the 9 corrections I have missing. Oh yeah, 10A didn't get written down, okay.